Hello everyone, let's practice some more with writing the ranges and domains of continuous functions. Continuous functions, because that's a little bit harder than writing the domains and ranges of discrete functions, because to write the domains and ranges of continuous functions, remember we need to be able to write intervals. So let's look at this function here. It is described by this curve. It's a curve with two endpoints. So let's take a look at what the range, let's first take a look at what the domain will be. What's the domain of this function? Domain. Well, remember that the domain is the set of all possible inputs, and remember that the inputs are graphed on the x-axis. That's the horizontal axis that goes left to right. This is a relatively easy continuous function because it has these endpoints here, and the first endpoint has the lowest y value, and the rightmost endpoint has the highest y value. So that's going to make this a little easier for us. So let's focus on the domain first. So the domain is all the values on the x-axis that the graph corresponds to, right? Like, what's the leftmost point on the x-axis that this graph has an input of, right? It's 11, because that's where the graph starts on the x-axis. And as we can see, the graph goes over this way, right? We have an input here, as we can see, right? If we go from the curve and look down onto the x-axis, that's therefore part of the domain, right? And of course, every single other part on the interval, other than those couple points that I'm noting here, the domain is this entire interval over which the graph exists, right? So this is the entire interval of the domain. How can we write this domain? Well, it starts at and includes positive 11, and it goes up to and includes positive 72. So that's the interval of the domain. We can write it like this. This means the domain is all x values within the interval, which goes from 11 and including 11 up to and including 72. Or we can write it as a compound inequality, like all x's less than or equal to 72 or greater than or equal to 11. These are all valid representations of the domain of this function. What about the range? Let's try to write out the range, right? Remember what the range means. The range means every possible output of a function. And remember that when we're graphing a function, the outputs of the function are listed on the y-axis. So let's look at this graph. What values on the y-axis correspond to this function? Well, the lowest value on the y-axis that this function corresponds to is positive 10, right? And then it goes up from there, right? You see it goes up from there. This is an output, this is an output, this is an output, this is an output, and so on, right? So this function covers the entire interval of the y-axis from positive 10 up to and including positive 67. So the range of this function is this entire interval here, and we can write it in interval notation. We can say it starts at positive 10, starts at and includes positive 10, and goes up to and includes positive 67. We can write it as all y values within that range from and including 10 up to and including 67, or we can write it as a compound inequality, all y values less than or equal to 67, but also greater than or equal to 10. So that's the range of this function, so we can write the domain and the range of this function. Okay, everyone, what if we had this function here? As usual, our horizontal axis is the x-axis. This includes all the inputs to the function that's represented by this graph. And our vertical axis is the y-axis. That includes all the outputs of the function represented by this graph. So let's say this function was just a straight line going on infinitely. That's what I mean by this arrow here. I just mean that this line is going to go on in the same direction infinitely. It's never going to stop, and obviously it's impossible to draw an infinite line, so that's what this arrow means. It just means the straight line goes on in that direction infinitely. So how in the world can we write the domain and range of this function? Well, let's take a minute and think about the domain of this function, right? Okay, what are all the possible inputs of this function? The function starts at 0, 0, so the first input is 0, and it's going to be an interval, right? Because it's a continuous function. Clearly, there's an input right here, right? Or right here. See, all values of x under which that exist underneath the graph of the function are possible inputs of that function, right? And since this is a continuous function, the entire interval on the x-axis from 0 actually all the way to infinity is going to be the domain, right? Because if this line keeps going in the same direction, right, therefore every single value greater than 0, greater than or equal to 0 even, on the x-axis is going to lie underneath this function. So therefore every x value from 0 to infinity, unlimited from 0 to infinity, is going to be a possible input to this function. So do we remember how to graph that in interval notation? We start at and include 0, and we go up to infinity, and we close that with a parenthesis because infinity itself isn't actually a number. It's just a concept to represent the fact that there is no limit to this domain. No upper limit, that is. The domain starts at 0 and goes on infinitely. So we can write this domain as all x values within the interval from and including 0 with no upward bound up to infinity. And what's the range? What's the range? The range is the same thing, right? The range starts at 0. Starts at 0 on the y-axis, and if this line just keeps going on infinitely, right, it's going to end up covering every possible value above 0 on the y-axis, right? So the entire interval on the y-axis from 0 and including 0 up to infinity is going to be the range. So, right, that's the exact same as the domain, actually. So the range also is every y value on the interval that starts at and includes 0 and goes up with no boundary up to infinity. Okay, let's finish up by looking at this rather strange continuous function. We're actually going to be looking at what can actually produce a function like this later in the class, but for now, let's just worry about its graphical representation and let's worry about how we can identify its range and its domain. So first, let me explain this function quickly. What I have, or rather what I mean by these dotted lines here, is that if we look at the bottom right of this graph, this means that this graph is going to continue downward infinitely, but it's never going to pass the x coordinate positive 7. Okay, so it's going to continue to go infinitely downward, but it's never going to go to the right of x equals 7. And similarly, if we look at the upper left-hand side of the graph here, what I mean by this upward arrow is that this side of the graph is going to go upward infinitely, but it's never going to go to the left of the boundary x equals negative 7. Okay, so let's start off by trying to figure out the domain of this continuous function. Well, what's the leftmost boundary on the x-axis? It's negative 7. So let's say actually not only will it not pass x equals negative 7, it's never going to even hit negative 7. Let's say that's a solid boundary that it never actually hits or passes. So therefore the domain is going to start at but not include negative 7, right? And it's going to go all the way over here, right? All these values on the x-axis are part of the domain because they're all the spots on the x-axis that exist either underneath or above the graph of the function, right? And it goes up to but does not include positive 7, okay? Those boundaries are hard limits that the graph not only doesn't cross, but it doesn't even touch those x values either to the left or the right, okay? So the domain is from but not including negative 7 and up to but not including positive 7. So we would write that as a compound inequality, let's remember, as x strictly less than 7, but strictly greater than -7. And we could also write it as the domain is all x values within the interval, parentheses -7 up to +7. And close those with parentheses because those boundaries actually are not themselves included in the domain. Okay, let's look at the range. What could the range of this function be? Remember, the range are all the corresponding y values to this graph, right? Let's look at how positive do the y values go. Well, if this side of the graph continues up infinitely, right, all the way up to infinity on the y-axis will correspond to this graph, right? If the graph keeps going up, it will continue to have infinitely large outputs. And same way, if this right side of the graph continues to go down infinitely, right, it will continue to have infinitely small outputs. All the way down to -infinity on the y-axis will correspond to the outputs of this side of the graph, right? So what is the range? The range goes from -infinity all the way up to infinity. Or we could say all real numbers. The range is all real numbers, right? No limit to the range. So we can say all real numbers, or we can say all values of y within the interval that goes from -infinity up to +infinity, which is of course the same as saying all real numbers.